Hello, my name is Hassan. In this video, I would like to demonstrate the pendulum experiment. One purpose of this video is to encourage any interested person to do scientific experiment. For example, if you're a student who is really interested in science but do not know where to start, or if you're a parent to a student who has some sort of scientific curiosity but do not know what kind of environment you can provide, I think this is the right sort of video, right sort of experiment to start with. There are a couple of reasons why I chose the pendulum experiment for my first experimental video. First, it's simple, as you can see, simple and very cheap to construct. I mean, it doesn't cost you any money, actually. The only things you need is a rope, an object like a tennis ball, your cupboard knob, maybe a paper which you can stick here, and measuring tape or a ruler, and any device that you can record the time, any stopwatch or your phone to keep the record of time. You can make this experiment a little more complicated by using also protractor to measure the angles and so on, but you don't need those for a startup case. And the second thing is it's tremendously instructive. You learn a lot of things with this experiment. You ask scientific questions, you make predictions, you learn how to test your predictions by doing control experiments. Besides, you learn the physics of pendulum and oscillatory motion. Let me briefly talk about how you construct this setup. You just tie a rope to an object like a tennis ball. If you're really interested in like how I did this tying, I can explain it at the bottom of this video, or make another video to describe how I did do it. But I think it's very easy to do. And at the other end of the rope, you attach the rope to any fixed point, which we call as a pivot. So it can be anything, like the knob of your cupboard or the knob of a door or any kind of apparatus that you can find at home, which doesn't cost you any money, so you can use it. So this is called the pivot point. This object is called the bob of the pendulum, and this is the rope that we used. Okay, what we are going to do in this experiment, we are going to measure the period. The period means the time it takes for this object to make one cycle if I release it. If it starts from here, if it moves like this and goes back to the same position the first time, it's called one cycle. And the time the object needs to make one cycle is called the period. So it's like 1 period, 2 periods, 3 periods, and so on. So it's the time it takes. So how are we going to measure the period? By using a stopwatch or any kind of equipment that you can use to measure time. Hundreds of years ago, Galileo used his pulses to measure the time for the period, to measure the period of the oscillations of a chandelier. So, but now we have the technology, we can use our phones to measure the time. So how are we going to start this experiment? We need to record anything important before we start the experiment. Okay, so I have a rope, but we need to record the length of the rope, right? Because we want to make sure that if we wanna do the same experiment again at a later time, we make sure that we know everything, every detail about our experiment. Okay. It is from the pivot point to the center of the ball, it's roughly 47 centimeters. And I wrote it down here. The length of the rope is 47 centimeters. The object used is tennis ball. I recorded it. The mass is about 58 grams. The reason why I recorded the mass is because I think it's important for the experiment, because I have a question in my mind. I think that maybe the mass of the object, if it's heavier, the period of the oscillation might be different. So that's why I thought that it might be an important experimental factor. And another important experimental factor might be the length of the rope. Another question I have in my mind is, if I make the rope shorter, what is the period going to be? Am I going to measure a longer period, a shorter period? These are the scientific questions that you can ask. Or if I release it from a larger angle rather than a smaller angle, are the periods going to be different? If they are going to be different, how much different they are going to be? Are they going to increase with the angle, or are they going to decrease with the angle? So those are the scientific questions that I can ask. So, but in order to answer such scientific questions, for example, the first question we can ask, so if I change the release angle of this pendulum, are the periods going to change? This is a scientific question, but in order to make an experiment, you need to change only one thing at a time. If you're curious about the effect of the angle, you only change the angle. So for two experiments, in one experiment, you release it from angle 1, which I labeled here, and measure the period of the oscillation. And another experiment, you only change the angle. You release it from a larger angle, which I label it as angle 3, and measure the period again for the second scenario. But in the second scenario, I did not change the length of the rope. I did not change the object I used. Everything else, other than the angle, I kept the same. That's how we do the control experiments. Okay, let me repeat it again. In a control experiment, you only change one thing at a time. Okay, now let's start our experiments. Let me start with a length of rope, which I noted down as 47 centimeters. The mass of the object is 58 grams. And the release angle is what I label as angle 1. As I said before, you can use a protractor if you want to be more precise about your experiment. But for my purpose, just labeling 3 angle points without any quantitative value of the angle will work for me, because I know that I can increase the angle going from the angle 1 to angle 3. I don't need any quantitative information. I'm just curious about the question, if I increase the angle, how the period is going to change. Okay, let's start with angle 1. Okay, I'm going to use my stopwatch to measure the time. Start from angle 1. Once I start, once I release the ball, I'm going to start the stopwatch. But it's going to be really difficult for me to measure only one cycle, because if I release it like this and stop the time as soon as it went back to its original position, I do not have enough time to respond. So my response time might bring a lot of errors. So to alleviate those errors, we just count 20 oscillations, for example, and record the time for 20 oscillations, and then we can divide the total amount of time to the 20 so that we can find the time it takes for this bob to return to its original position for one cycle. Okay, let's reset the timer. Let's make sure we start from angle 1, and I start it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I stop the stopwatch. Okay. So it's 27 seconds, 50 milliseconds. So I note it down here. I have a table here. For the small angle, which I labeled as 1, angle 1, my result is 27.50 seconds for 20 cycles. But I need to divide this to 20 to find the period of the oscillation, the time it takes for one cycle. So there are 3 lines here, which I labeled as test 1, test 2, test 3, because I want to repeat the same experiment with the same experimental conditions so that I can have an idea about my errors related to my measurements. So what I expect is I expect almost the same value for the second and the third test to make sure that I am not doing something wrong. I am coming up with and finding precise results, okay, to make sure that there are no significant errors associated to my measurements, okay. So another thing which is important is when you try to do the same experiment again and again to just have an idea about the errors in your measurements, you don't change anything. You just repeat the same experiment with exactly the same conditions, and it's going to give you an idea about the reproducibility of your results. Okay, let's make another test, a second test with exactly the same conditions. Okay, I reset my timer. I start from, again, angle 1. My rope length is the same, my object is the same, my release angle is the same. Okay, and I start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And it's 27.41 seconds. I note it down here. 27.41 seconds. It's very, very close to my first measurements. So it makes me happy because I know that my measurements are very close to each other. They look reproducible. Let me do this test one more time, one last time. And that's going to be test 3. Okay. I reset the timer. Put it here. I again start from angle 1. Okay, I don't change anything. Okay, let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah. So it's 27.46. Very, very close to both of my first 2 measurements. 27.46. 1.46 seconds. So this is the time for 20 revolutions or 20 cycles. But if I have 3 results for the same experimental conditions, and hopefully they are very close to each other, you can take arithmetic average of these 3, which is called the mean of the results, and by adding these 3 time values and dividing the 3, that's going to give you the average value for your for 3 of your measurements. Let me use the calculator of my phone to estimate it. 27.50 plus 27.41 plus 27.46 is equal to 82.37, and if we divide it to 3, the number of measurements, it's going to give us 27.46. 27.46 seconds. But this is, as I said, for 20 cycles. If we divide this to 20, we find 1.37 seconds. 1.37 seconds for 1 cycle. So the period is 1.37, okay, for this measurement. Okay, let me turn on my stopwatch, reset it. Okay, let me put it here. Now, what am I going to do? So first, before I do anything else, I need to look at my results to make sure that everything is going smoothly. Okay, we see that 3 of our tests are very close to each other, and we found the period of the oscillation for length is equal to 47 centimeters, and for the mass 58 grams. Now, to do a control experiment based on our question of if I change the angle, the release angle, how is my result going to be affected by that? To answer that question, we need to change the angle. We need to repeat this experiment by releasing it from another angle. Let's make it angle 3, which is the large angle case. Okay. But I keep the length of the rope the same. I don't touch it, and I keep the mass of the object the same. So I use the same object. Let me repeat the same experiment again 3 times, but this time releasing at a larger angle, which is angle 3. Okay, let's do this experiment. Okay, let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 27.82 seconds. Very close to my previous results. Wow. 27.82 seconds. Okay. So this starts to tell me something. I find very similar value to the one I found with the small angle. But I need to repeat my experiment 2 more times to make sure that there is no error associated with that, to make sure that I did the counting correctly, to make sure that I took I recorded time very precisely. My response time was very precise with respect to my other measurements. So I need to make sure that my results are reproducible. Okay. So to do that, I need to repeat exactly the same experiment with the same length of rope and with the same object and with the same large angle. Let's repeat it again. Okay, let's start. Let's start from here. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 27.88 seconds. Wow, it's very, very close to my previous measurement for 20 cycles. So I'm going to divide this to 20 to calculate for one cycle. Let's repeat the same experiment the third time. Okay, let's start from angle 3, which is a large angle. Okay, let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, it's again 27 seconds and 96.90. 27.96 seconds. Okay, now I calculate the mean for these three values. Okay, I use my calculator of my phone. 27.82 plus 27.88 plus 27.96 is equal to 83.66. If I divide this to 3, I find 27.89. 27.89 seconds. If I divide this to 20, I find 1.39. 1.39 seconds for one cycle. So for the small angle, I had found 1.37 seconds in average. Now for the large angle, I find 1.39 seconds for one cycle. They are very, very, very close, almost the same. Especially when I consider the amount of errors that I can make, because I know that my response time is not going to be perfect. So it might involve some fraction of a second, and if I divide it to 20, it's going to be maybe 100th of a second. I may have some errors in the order of 100th of a second. So this is basically within my error margin, which I can conclude that even if I make a larger angle, the period of the oscillation I find almost the same. So this is my scientific conclusion. Okay, next thing you can do, you can ask the following question. How about if I change the length of the rope? It was 47 centimeters in these sets of experiments, but let me use a shorter rope like this. Okay, let me do it like this. Okay, so it's going to be shorter. Okay, let me measure. I need to measure this, and I need to record it to make sure that if I want to repeat this experiment again later, I will be able to. Okay, so this is around 25 centimeters, second set length of the rope is 25 centimeters, right? Let me repeat it. Yeah, 25 centimeters. Good. Now it was 47 centimeters. Now it is 25 centimeters. Something maybe half of the original length. Okay. Let's see if I make it shorter. Let's see whether I'm going to find a smaller period or a larger period. Okay, let's see. This is the scientific question, and I can exactly answer it by doing experiments. Okay, let's repeat this experiment for this case. I'm not going to change anything. I can use a small angle case. I need to use exactly the same object, the tennis ball, and I'm going to repeat this experiment again for a shorter length. Okay, let me set up my stopwatch. Okay, let's reset it. Let's repeat it. Okay, let's start from either way. I mean, I can start from a larger angle or a smaller angle because I have the data for both cases. But let's start from the reason. Yeah. Okay. I know that the angle doesn't matter, so let me start with the larger angle. Okay. Now, then I start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20.1. So for this one, test 1 is 20.10 seconds. So it's shorter than the previous result, but let's repeat this test one more time. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20.40, which is very close to my previous results. And this is test 2. I feel comfortable and I don't want to make a third test. I'm going to make the arithmetic average of these two numbers. If I do that, 20.10 plus 20.40 is equal to 40.50 divided by 2. It's going to give me 20.25 seconds. If I divide this to 20, it's going to give me 1.01 seconds for one cycle. So let's summarize our results. If I used a rope of length of 47 centimeters, I found the period to be around 1.37 seconds or 1.39 seconds within this range, depending on the angle. But in the second case, I used a larger angle, so it was around 1.39 seconds for the longer length. For the shorter length of 25 centimeters, I almost halved the length. I found a shorter time, which is not 1.39, it is below that value. It's smaller than that. It's 1.01 seconds. So if I go back to my experimental my scientific question: how is the length of the rope going to affect the period? The answer is, if I make the length of the rope shorter, I found a shorter period. And this means faster motion, because it's going to take smaller time to make one cycle. And you can repeat this same type of measurements by changing the mass of the object. You can use a ping pong ball instead of a tennis ball, or you can use a key ring instead of a tennis ball, and you can make these measurements again. I strongly recommend you to do that. I'm not going to do it for you right now in this video. That's going to be a really good exercise for you, and if you share your results with me as a comment under this video, I would really appreciate them, and maybe we can have some time to discuss about your results. Thank you very much for watching me. If you can choose to subscribe to my channel, if you can choose to subscribe to my channel if you want to get alerts about my upcoming experiment videos. Thank you very much for watching me. See you in next videos.